time. So hey y'all, it is the 29th of July, 2024. We are here for Cardano Go Live Coding. We get together on Mondays to start the week, 1300 UTC. And we've been building an indexer for a project, and we can take a look at it. Let's go like this. All right, there's the result. But here I made a few updates. What we talked about last week is logging periodically, so you can see that's happening now. I think this is going every 10 seconds now just because I wanted to see it. You can see when it's catching up to tip, it's taking the percentage now, and now we're at tip, so 100%. If I make a request, you can see there's some logging here. So it's simple. I didn't try to do too much with the logging yet. But once again, if I make a call to auctions, boop, then the log is down here, and we can, if we need to do more with that, we will. The request itself has been updated, so we're no longer saying HNS token name, we're just saying token name, and then we've got the policy ID of the DNS token here, which is understood to be what it is. So we were able to just use that. And this is the new golden image. So we're synced up on a SQLite DB file that's just in the Git repo, so anybody else can sync from here. But this has the dot, the digitalis, Blink Labs, Hypnotoad, Gimbalabs, and Andamio so far. And this will include a little surprise by the time we get to Rare Evo in a couple of weeks, right?
Yeah, absolutely.
We'll have a
Absolutely.
list of domains ready to go.
Hmm.
So that's the results of some updates. I'm feeling pretty good about this. I haven't applied any kind of like Docker image to it yet, but I'm happy about the changes. And so what I was hoping we could do is a quick code review here, just to make sure that the Blink Labs team thinks things look good. And then if they do, two things can follow. One is I can just copy this to be the DNS info indexer. You already have one that's actually serving DNS, but I'll make one that's just consumable by the front end for quick queries. That I think we talked about, that'll just be useful to have. But
Yep.
then the other thing I want to jump into today, more importantly than that, is now taking another look at the Go PBL course outline. And now that we've gone through this, seeing how this fits and maybe refining the learning targets a little bit, because in August, I'd like to start building that course. So quick, let's do code review first. It's pretty straightforward. I didn't do much to the indexer, other than what we talked about. I'm not even sure what we even need to look at here. Like, I don't really have a plan for what to review. If it works, should we assume it's good enough? Or is there anything that you think is worth zooming in on to make sure it looks good?
I think
If
it's
it works, if it works in general, it's probably mostly fine. But there's probably some gotchas you haven't encountered yet that you don't have handling for. Things like rollbacks or resuming the chain sync after a
Right.
restart if there's been a rollback in the meantime, or it's all those weird edge cases that you don't hit until you run it for a little while.
Exactly. And that's a great reminder. We need to implement rollbacks. And I've done that once before. So that's a perfect reminder, is to get that. Aurora, when you think about that, what are some other gotchas that are worth paying attention to?
Um, The only other one that I actively run into is dealing with contracts and collateral collection, but that's probably not going to be a concern here.
Right. Well, that's helpful. Yeah, that might not come up here. But yeah, as we start to think about a course, like building a situation where maybe we show that a little later on will be interesting. So that's worth noting. And so maybe the best thing to do is let me take offline implementing rollback handling, continuing with the idea that if it works, it's good enough.
I
Get
can also
rollback.
tell you,
Yep.
well, we also run all of our code through several different linters and checkers, and not all of it is stuff that we put in our CI pipeline. So like in our tests we use what is it, GoLeak, which is something from Uber, and it will actually detect whether you're leaking Go routines. So like we use that in like
Is that
Adder,
like
especially
this? Go leak,
Go dash leak, I think.
go dash leak.
Yeah. And then we use Golang CI dash lint, which that guy is always in our actual CI, but yeah, it's Golang CI dash lint.
Golang CI.
No, it's Golang CI, like all
Oh
one
yeah, I
thing.
got you.
Yeah, it's
Okay.
yeah. Anyway, yeah, we run that one, and Uber has another one called Nilaway, which I like to run, and
How do you spell that?
NILAWA, like
Nil.
nil way, but one word. Yeah, and I use that, and what it detects is places where you're not catching pointers, where you're using pointers and stuff like that, but like you're operating on a pointer without checking that it exists first.
Very nice. Oh,
And the problem with those is they'll pass they'll pass the compiler, right? So because it isn't always going to be empty, but sometimes it can be, right? So like what this does is it traces down through, like all of the basic paths in your code and looks for places where you're not, checking that something is nil before operating on it, which would cause a runtime panic instead, right?
and you said it's tracing pointers.
Yeah, so it's looking for all places where you're basically using a pointer and you're not checking that it's nil before operating on it, before doing
Right.
something.
It's not just pointers. It also applies to interfaces and any other type that's nillable.
Yeah.
But I mean, interfaces are pointers under the hood anyway. But yeah.
Yeah. Yeah. It's
Right. Okay.
yeah. So this one can potentially like have false positives. So it's not one that you necessarily want to slap directly in your CI workflow.
Sure.
But I run that pretty often to check stuff and just try to clear out the low hanging fruit. And my point with that is it's just it's good, to like help clean up the hygiene and find things that you might have missed, right? You know what I mean? And especially with Go's like explicit error handling everywhere, right? It helps find places where you might not have thought about handling errors.
Yeah.
And over time, you know what I mean? Like you pick up a better pattern. So like some of the stuff is really kind of about like training myself.
Right. Exactly. Exactly.
Yeah, appeasing the linters has definitely improved the code quality I write, because it's like I'm now keeping it in mind. Well, I want this to pass checks when I first put up the PR. I don't.
I was actually
So I'm going to do it right.
directly thinking about that. That makes so much sense. Yep. Yep. That's great.
Yeah. Yeah. I mean, like, and again, some people don't like, putting too much stuff on it. And I'm like, if we don't care personally, right, then there's no reason to like not necessarily then to avoid like accepting someone else's opinion.
Right.
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 So like if I don't care, then whatever the linter says is fine. That's what we're gonna do, right? You know what I mean? And
Exactly.
you know, so it makes it a little easier because you end up, and this is like one of the things that I like about Go, and one of the things that other people hate about Go, is that like Go code all kind of looks the same. When you pick up a new Go code base, you can go pick up someone else's code base and pretty much dive into it and start understanding it pretty easily because it all looks the same. Right. And a lot of people don't like that because they say it makes Go code boring. I think it makes it exciting because it makes it easy to implement the things that you
Supposed to
want.
be
It makes it
boring.
easy to.
Ideally, it is boring.
Yes, right. Exactly. It's
It
like,
is designed to be a boring language, a boring and reliable, performant language that's easy to
right,
maintain. Like, yeah,
Right.
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 Yeah, exactly. You know, if I want to get super elegant, you know, you drop to like C or assembly or do something crazy, right? Like, you know, but like otherwise, I just want to get stuff done.
That's really cool. And this is, I love that idea of just trying some of these linters and tools just to find out what our opinions are, and that'll help me get ready for the course as well.
Yeah, absolutely. And then of course, like we use Go format for formatting the code. So it's Go FMT. We use the built-in one. Yeah, not the no. Yeah, there's actually a Go FMT and Go space FMT. We use
Okay.
Go space FMT, which is the built-in one.
So like an underscore.
No space. Yeah,
Oh,
no, just space. It is
right,
Go.
right. The built-in, right? Yeah, got you.
Yeah, yeah,
yeah,
yeah.
it's a sub command of the Go toolchain.
Is that I think that runs just when I save a file? Is that the one?
Your
I
editor
don't.
might do that. Like I've got my Vim is set up to do that, to run Go format automatically on write of a Go file.
Okay. I think so. Okay, but I'll double check. And I think it's good to run that command and see it.
Yeah, and then another one that we personally use is Go lines, and you
Oh,
can.
that's one word.
Yeah, and you can go look at like any of our repos and look at our make files and see how we use it. But it again just gives us like specific formatting, right? So like the Go format has specific requirements, and essentially Go lines is slightly more opinionated, right? And one of the main things that it's used for is for splitting long lines. And you know, so like we try to keep our stuff within 80 columns
Yeah.
as much as possible. So that's what we use Go lines for. And so it'll take all the stuff that's too wide and you know split it where it can, you know, in places where like Go doesn't care about it, right?
Right.
You know what I mean? So like you know, for example, you're like if error equals, you know, data semicolon error equals, right? Like it might split that if it goes too wide. And again, that also helps provide uniformity in all of our code.
Right. Well, I just wrote a really wide comment to test go lines.
Yeah. It won't touch the comments unless you tell it to.
Yeah, I'm actually curious how Go lines would affect that long comment. Yeah.
Nice. All right. Well, I'll report back on that next week.
Yeah, yeah. So I mean, and believe me, it'll tell you, especially Nillaway. Nillaway is going to be like the one that's gonna hurt your feelings.
Yes. 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 Good. Good.
It's gonna be
Oh,
like,
yeah.
oh,
Nillaway is obnoxious, but the problem is it's right. And even when it's wrong, it's technically right.
yeah, yeah. Like we've had a couple places where like I've made Nillaway happy, and it wasn't necessary, but it was necessary, right? You know what I mean? Like we're like, it is
Right. Stuff like
impossible.
yeah,
It is.
there was a case where like you were getting command lines from the standard lib, and because it returned a byte slice, it could be nil, even though it would never, ever, ever
Right.
actually
Yeah.
in
Yeah. Yeah. Yeah.
practice.
Yep. Yep.
It's like, no, you got to fix that.
Yeah, yeah. So I fixed it just to make Nillaway happy, you know.
I'm sure I'll get productively stuck with a few of those messages, and that'll be fun to bring to the team.
Yeah, absolutely. And there've definitely been a few of those where I've been like, okay, I have spent like, 10 minutes playing in this loop here and I don't understand. And, like Aurora will come take a look at it and help out. So,
Yeah, there's been one of those where I had to stare at it for like 45 minutes, and eventually it was like, oh, just like you create an intermediate variable because it was like nested map lookups or something, and it's like, well, it could be nil here in the middle, so you had to do like assign to an intermediate variable, check that for nil, and then access through that intermediate variable, and then nil away was happy, you know. But it was not obvious from the error and looking at the code what it actually wanted.
It's really always such a relief to hear these stories. Thanks.
yeah, yeah. And I mean, and that's the thing is over time, like you do end up writing better code,
Right.
right?
Exactly.
Again, you end up avoiding these types of issues, and the way that I look at it is you're avoiding issues that are easy to automatically detect. And if you're
Correct.
avoiding them in the first place, it means that like your bugs are subtle.
Right.
Right? Like your bugs are real bugs. They're not
Right.
like, oh, I forgot to nil this or whatever, right?
Yeah.
Like they end up being things like, oh, my logic is completely wrong. So I'd say it, improves your code quality, but it also ends up making your bug hunting a lot more interesting.
Right. Because you can really get to the good stuff. Yep. I was just going through this with a different project, where we just have a whole bunch of warnings, and to address them is 100% just to write better code. Like, sure, it works, but when you see those things and they're giving you the right message, it's really, really nice to understand those patterns better. I do think that's a great way to understand patterns.
Yeah, and I mean, and the nice thing about all the automated linters too is, at a certain point you can tell them to ignore stuff. Right.
Right.
So, I mean, you can get to a state where I'm going to say, the linter passes, even though you've ignored things. And then you can create like follow up tickets for cleaning those things up. And like we do
Right.
that sometimes too, right? To where we're like, okay, like this one's squirrely. So you just slap an ignore on there and then create a ticket to go back and figure it out later.
Exactly. And I'm comfortable doing that in TypeScript. I'm just not there yet with Go, but like that's absolutely the experience, right? Is yeah, okay, I understand this well enough to know that I don't want to deal with this particular warning right now. Let's ignore it. And clearly there's a good reason to come back to it later.
Yep.
Cool. Well, so okay, this is interesting. This is making me think of module 301 in the course. If I open this. Oh, what's that? Um, so here's our course outline. We'll go backwards in just a minute, but module 103 is where we initially thought about including a lot of this adder stuff. And I think
Yep.
at this point, we've got these learning targets pretty well covered by this project. And I think I can run with it from here, breaking this down into parts, little tiny lessons, code examples, and we can get this going. And where we're going eventually is module 301, what to do when none of the above actually works. I'm
Right.
excited because I think the next steps for this week are going to help get some ideas here. So I can come to you with questions next week and say, okay, well, here's the things that didn't actually work. I got this linting message from Nilaway, and I didn't understand it, but maybe that'll give us some fun ideas for what to add here.
Yeah, absolutely. Absolutely. And then also, like what different ways you can use for trying to troubleshoot stuff. Um,
Yes.
you know, like you'll notice that we have Yeah. You'll notice that we have on most of our stuff debug port,
Yep.
and you can use that with the Go profiler, right? Um, yeah. So yeah, the Go profiler, and that tells us a lot of what's going on. Many times when things go awry. And then like we to answer this, like we'd really have to go through and think about like what things we're wanting to find. So like I think it would be more looking at the above stuff and trying to come up with like actual failure scenarios,
Yes,
right? Like
exactly.
what if your seaboard doesn't decode? What if you run into a block that causes a problem, right? Like just those sort of things, and kind of lead someone around how to handle that.
And ideally, by the time students get here, we are able, like in an introduction to this module, to say, actually, you've been seeing this throughout the course. And we can give like a
Right.
bullet pointed list of back in module 102, you saw this and we showed you how to that, right? And just a list of
Right.
examples like that. And then we can just generalize here.
Yeah, absolutely, absolutely. And then also, like we can give a couple examples, right? We can try to come up with a couple scenarios that we
Right.
can them through essentially.
Cool. So we are going to get to reacting to chain events, and we could talk in just a second about if this is the right name. But it's been a few weeks since we've looked at this outline, and so let's see how it reads as of now. Last we talked about the course, we thought a 100 module with some prereqs and tools that will be optional. But for anybody who's starting from scratch, highly recommended. So Cardano background knowledge, Ouroboros background knowledge, touch on Apollo, Bursar, and Adder, just in terms of showing why they exist, and
Yep.
then introducing people to Cardano up so that they're aware of being able to run that. How does this look?
Looks good.
Do we need to add or remove anything? Would you do things in a different order?
No, I think that's fine.
Here's Cardano, here's
I mean,
Ouroboros.
okay, actually, maybe I would swap Apollo and Bursa.
Wallet, right? Because you can play with a wallet before you're building transactions. So some wallet
Yeah, I mean,
functionality,
yeah,
some
you can.
transaction, and some query functionality.
Right, right. I mean, because the idea kind of is here, like you're talking about Cardano blockchain, right? Then you're talking about Ouroboros and like how the networking works. And then when you're talking about Bursa, in this case, what we're basically talking about is addresses, wallets, stake keys, right? You know what I mean? The things that are like those primitives. And then we move on from that to, okay, well, now what can you do with these? And that's Apollo, right? You see what I'm saying? So it's like we're kind of
Right,
progressing
exactly.
into a more specific and more specific items as we go along. And everything is, like, well, how do I use that previous thing I just learned about? Right. It's like, oh, okay, Cardano blockchain. Cool. Well, how does that work? It
Exactly.
works with Ouroboros and it does this, and that's how it makes blocks and transactions. And you're like, oh, cool. Well, how do I make right?
Exactly. Okay, perfect. Oh, we're so aligned on that. That's great. So yeah, we can add just a little bit there. We've got like the boilerplate here just from an earlier preview.
Yeah.
But exactly, connecting these lessons in a narrative way and building from one thing to the next. That's
Right.
where we're at. All right. So now we've kind of set the stage and given some reasons to keep going in this course. Now that we've introduced this stuff, and we're going to show you how to connect to the network by a few different methods, but and those are built into Cardano Up.
Mhm.
And then we say, okay, well, now that you've got a node running, let's interact with it. So we were going to use the starter kit on Demeter run, because that way people don't have to have anything running locally and they can just learn a bit about this.
Right.
Fetching specific blocks and thinking. I don't know what we meant here. I can check.
I can synchronize.
Or were we talking about, right, actually synchronizing or just checking your state? I'm going to say for now, check sync state. But then if we realize we actually, that might be enough to specifically show people. So this starter kit is working, right?
Yeah.
And then given you have access to Goroboros, fetching specific blocks, checking sync state, checking the mempool.
Yeah. So all of those are things that are already in the Gorobros starter kit.
Yes. Okay. Okay.
And so I think the idea here would be, like you start with the starter kit, you show what the starter kit itself has. And, in every case, it's the simplest case, right?
Right.
So the idea is you show them the starter kit and then potentially show them one change they can make to it to do something different.
Right.
And then just kind of leave them alone, right? So it's like, oh, okay, well, here's how you get a block. It's like, okay, well, like what can I do with that, right? Right.
Great. Okay. So these things in your reading of these learning targets, it's going to flow from one to the next pretty nicely. Run this thing within there. Here's how to do this, this, and this. It's all covered.
Yeah, probably the only thing that's not is submitting a transaction, and that's just because we skip it because it's a whole section, right? Like,
Save it for here. Okay, so
yeah,
then we say, okay, creating the wallet, building the transaction, signing, and then now we come full circle to Goroboros, submitting.
yeah, and actually, you can't sign it with Bursa.
You
You
can't.
sign it with Apollo.
Oh, you do?
Yeah.
Versa creates keys, but the signing step is done by Apollo.
Yes, at this point.
Okay. Great.
Like, I want to have a way to do it, but the main issue that we have is we don't have any UTXO store or anything like that in Bursa yet.
Okay.
And so when we use Apollo for this stuff, like in Bluefin or whatever, I've already indexed and kept all of the UTXOs and all of that sort of stuff, right? And we're generating the transaction, so we know we need to sign it. Right. But with Bursa, like I wouldn't necessarily know that. So what we would have to do is we would have to make it act a little differently, and we plan on doing that. It's just not there yet. So at this point, we'd just sign with Apollo.
That makes total sense. Okay. And so from a narrative perspective, all right, now we motivated why we need Bursa. Here's how to actually use it. Let's create that wallet. Let's now build a transaction. Let's sign it here, submission here. And then, transaction building is going to keep going. We're going to come back around to it at applications and smart contracts. But for
Right.
now, let's talk about one detail of transactions. Let's set a validity interval and show the impact of that.
Yeah, so that's a good one. Another one that actually would be easy for us to do would be metadata.
Uh-huh.
Set set metadata, on a transaction.
What if we make that the assignment too? So we can say, okay, you're about to learn another thing.
Sure.
I guess there could be a unique learning target about that. But yeah, here, let's try that here.
Yeah, so I would explicitly do like the crap, I don't remember what it is, like SIP20 message, like metadata message.
Yes.
Yeah.
Yes. Love that. So we could even introduce, we could say, here's how to add trivial metadata as a learning target. And the assignment is read SIP20 and implement the SIP20 message standard.
Yeah.
That's pretty cool. Okay, so watch this. We'll go here.
And the reason why I was talking about that is, yeah. Well, oh, okay. I was gonna say I can add. Yeah, no, that works.
It's
That
a
works.
placeholder for now, but we can change it.
Yep. Yeah.
But no, what were you going to add to it?
Oh, I was gonna say the SIP20 stuff, but it's fine. So the nice thing is when we get to reacting to chain events in 103, right? Now we can actually look for metadata.
Bingo. Yes, yes, yes. Okay.
And so the thing about that is to look for metadata, you're going to want to use like Adder as a library, right? Because it's going to be something that you're going to do in your handler.
Bingo. Okay, so at the end of module 102, to demonstrate success, the assignment in 102 is going to be to follow this standard, SIP20, to
Yeah.
post particular metadata on chain. And
Yes.
then in module 103, we're going to say, well, gosh, oh, all these students are putting metadata on chain. Now let's look for it. And
Right.
that immediately motivates this module. With metadata being the first application, it's a really nice thing that people can understand. And then we say, okay, well, now that you understand some patterns around metadata, obviously there's a lot of other things we could look for.
Right. And we can also talk a little bit about metadata itself and the fact that like it's not authenticated data, right? So it's anyone can put anything in metadata. So it by itself is only like, let's say you'd use it as like a hint.
Right.
Right. Right. Whereas like, yeah, exactly. A datum is validated. So the point is like metadata would be something you would use more along the lines of, like I want to check that it's this address and this metadata.
Yes.
I check that it's that address and this metadata. Right. So, like MinSwap, for example, uses metadata to tell you what action is happening with the smart contract.
Right.
Right. Even though you might be
Right.
interacting with the same address, are you depositing or are you withdrawing? Are you right? You know what I mean? And those both are valid, and both are a spend in the smart contract, right? So you know what I mean? It's just a question of which direction you match, and that isn't necessarily apparent from just the data that you're putting in.
Right. Right.
Right. So it's like, so they just slap this extra metadata on there just so that oh, I'm
Yeah.
withdrawing from a pool or,
Right.
adding to the pool. So yeah, I mean, even the examples that they use is stuff like, oh, you can put an invoice number in there or so that's the idea is it's not necessarily something that you want to trust unless you
Right.
also add something you can trust to it. Like, oh, it's on MinSwap's smart contract address.
Right. Well,
I
and
know
once you
now that
trust it, right, whether it's the address, the policy ID, or even better, the validation logic that leads you to
right.
trust the parts you have to trust, then this kind of metadata really is like a convenience thing. Look,
Yeah.
this shouldn't change whether you trust a thing. but it certainly is helpful once you do.
Right. Well, interestingly enough, metadata cannot be read by smart contracts.
Exactly.
Right.
Exactly.
So, that tells you its trust factor, right? It is not validated. It can have anything in it.
Did you see? I saw did somebody put out an experimental solution. They said, well, basically you can recreate the entire transaction. So if the metadata matches, you'll get the same transaction hash. And then basically that unlocks referencing metadata in a validator. But
Yes.
that was kind
Yes.
of
I did see
interesting.
that.
That was a cool thing. I had never really thought that far, but that was pretty cool to think about. Not
So,
sure what the application of that would be, because if you really need to validate against it, it's just not that hard to put it in Datum. But
so the idea was to be able to use it in SIP25 NFTs,
where stuff had already been created.
where it's already been created, it's already on a SIP25. There is no datum, there's no SIP68 with
Right. And now we
right?
want to be able to do something. Yeah.
Right. So, they're saying that you could enforce things. Like one of the ideas is be able to enforce rarity.
Right.
You build a rarity chart or whatever of some, like NFT drop, right? And now because you're able to validate the metadata, you can actually validate the rarity essentially of the thing by, going through the rarity chart, figuring them all out and all that stuff. And you can enforce the pricing, right? Like right now, pricing and based on rarity and all that sort of stuff is entirely based off of just whatever the user puts in, right?
Right.
And it's entirely social for what things have like the right values or whatever. But,
Right.
it would be interesting, to be able to put that directly into the site is essentially the idea. And, you could actually create enforcement on that sort of thing.
That's interesting. So that actually might become an interesting extension project. Just playing around with what would be the steps to get there. Not going all the way to implementing that, but I think there's opportunities to kind of lead more advanced students on a little thought experiment there.
Yep.
All right, cool. All right, so we've generated metadata in when we build our transactions and in some assignment. There's going to be specific parameters here. And anybody who follows that, A, has proven that they understand how to do this thing, but they've also created some data for then us to start playing around with here. These seem pretty straightforward to me. How does the order feel? You got to run it
It feels good. Yeah. No.
right here, filter by event, and then filter given transaction events. You can filter by address, policy ID, pool ID, that's fine. And then we'll build a little something. And this really leads to the assignment.
Yeah. Yeah. That leads to the assignment for sure.
Yeah.
And in the assignment, I think that's where we kind of throw them for a little bit of a loop. And that's where, we give them the idea of having them filter for the metadata.
Yes. Yeah, yeah,
Right.
yeah.
Because we're showing them how to use Adder as a library. So they're already using it as a library, which means they're writing an event handler for their event, right? So the point is now they're going to have to take that transaction object or whatever, the event object that they get, and figure out how to inspect it, how to do something with it.
All right. Cool.
Yeah,
Yeah, exactly. Whatever that ends up being, but that's exactly
yeah, yeah.
the idea. Okay. So that
But I mean, it's
all makes sense.
Yeah, I think the idea with that is you build it, you tell them how to filter all the things that are like built in, right? But like your logic is definitely going to be something more than that. This is like how to focus, right? Like adder to where you want to run your logic, right? You know what I mean? So it's like because
Right.
you're going, it's like you learn how to filter the event types, you learn how to filter by like let's say address and policy ID and this sort of thing. It's like, all right, well now you know how to do all of these things, and now you're going to get events that only match those things. And now we want you to pick a specific type of transaction out of that event by some other criteria that's not a built-in filter,
Right. Right.
right?
Exactly.
And so that's why we'll just do the metadata thing because it's not hard, and we've got examples of it in like TX top and our stuff. Just there's examples of it of filtering through to the metadata so that you can use it to determine whether or not what type of min swap it is and that sort of stuff, right? So I have it in there. My and again, it's not that hard, but it goes beyond the built-ins of Adder, which is kind
Yeah.
of nice because again, we're showing people the things and then showing them how to expand beyond it, right?
And
And
sorry,
that's
when you say you have it in there, where was that again?
TX top.
In TX top. Right.
Yeah,
Yes, yes, yes. That's a great example. Okay.
yeah, because it does a lot of that.
Right. Very good. That's really cool. Okay. Good. No, that this is a really good story and it's fully achievable based on everything we've got already.
Right.
Then we
For the most.
distinguished between reacting to chain events and now jumping into querying the blockchain because we thought we might look at providers. So
Yeah,
here we're like kind of showing you play with Adder, but we're really not going into the full implementation of an indexer. There's a little bit more we have to think about. So
yeah,
basically, we give people a chance to play with Adder, get familiar with it, and then we say, okay, well, using these tools in production, you're always going to be querying the blockchain somehow. Here's just
right,
an intro into how to use something like Maestro. And then
right,
here's tying together module 103. Let's really talk about the effective implementation of an indexer.
right, right. And the biggest thing really that converts it from just being a fence into an indexer is the storage, right?
Yes, exactly. We get from module, oh, sorry, 103 to here.
Yeah,
It's really storage that we have to think about. Right. I mean,
right.
that's
Yeah, and your choice is, skip it, right? Use a provider. That's
right,
always you can
right,
always do that, right? And in a lot of cases, that might be the right option, but in other cases, you want to build it yourself and store the data yourself.
right.
And we find that this is most important, when it comes to building an application with stuff. As you said, like we're building towards building an application, right? And I think the next module is kind of an application. And it's because, yeah. So it's like at this point, we're kind of like building an application, right? And so to build any of this kind of stuff, one of the things that we need is the historical information of stuff. Like,
Exactly.
a great example is when you get an event from an index, or sorry, when you get an event from like Adder, right? It only has the outputs and the references to the inputs,
Mm-hmm.
right? So if you don't have a way to resolve those inputs,
Mm-hmm.
you can't build a transaction, right? Like you can't, you don't know what's been spent. You just know it's some like you have to have some storage somewhere,
Right.
whether it's right to know what that thing is that's being spent. So you have an event of what happened, but you don't really have a why it happened or like how it happened without having the indexing, which allows you to store the historical data and query it also. And, so the big change there is, so it's like you have reacting to chain events, you have querying data, but then when you get to the application, you're blending the two of them essentially, right? So, like a common use case would be resolving the inputs on an event. And so this could be something that you could do in your adder pipeline, right? And we did this in the Builder Fest, right? Where we queried Kupo in the middle of our handle event to query it for the inputs so that we could resolve them. We could know what address it came from. We could know the amounts, right, of all the inputs of what was in that input UTXO. We resolve it and return it. So now instead of getting an input that's just an ID and an index, you get an input that's ID, index, and then the actual like contents of that UTXO. Even though it's spent and not technically a UTX, but that transaction out, right? You get the contents of it, as the input. So you're now able to you get a complete view of that transaction.
Right.
Right.
When you need it. And so this is cool because now we start talking about applications. We're going to build particular kinds of transactions. Let's talk minting. These two, you are easy to show people without needing query state.
Right.
But that's really here where we then say, oh, okay, now really most of the time you're going to need some information from somewhere. You need to know about
Right.
And so really now we jump into that here. Oh. So now things really start to come together into applications. I don't remember what we meant by this. I'm going to leave it here for now, but it might go away. And then obviously now we can touch on, okay, like Chris, you were just talking about knowing the inputs to a transaction when that's helpful. Another example as well, from those inputs, being able to look at datums, being able to assess redeemers, tie it together, building an app that takes us into an assignment. Although now serializing data, okay, right, we introduce a little bit of datum and redeemer here, but then we say, let's get into some deeper details about serializing.
Yeah. I mean, especially when, like our datums and redeemers for our first, lesson can be trivial, right? We, like you said, introduce the concept. It's like, okay. And then in practice, you'll find datums that are right, much more complex and go into that.
Exactly. Love it. Okay. That gets us here. Some debugging stuff. All right. This is good. Okay, so I've got some next steps that I can take looking at some of these tools and extending the indexer, hopefully getting stuck on a few of those things, and I can bring questions next week. Either way, I'll share some quick updates, but then we can really start to dig in here. I think our next step for the course is just to start mapping to the specific links to all the examples that we have already. I think we've talked about a lot of them here, and I can flesh out the easy ones, and that'll give us a way to figure out the backlog of like what examples still need to be built. My experience is once we have examples to reference, the lessons often write themselves, especially when we're being this thoughtful about the course sequence.
Right, right. Yeah. I mean, again, someone being able to do this and, go through this will be able to, write backends for sure for whatever.
That's the
Right?
idea. Oh, I want to see that process come to life so bad. Like it's gonna be so satisfying to build a sufficient course here so that we can really test that hypothesis, right? Does this help us actually find some people to join the teams that need them?
Yeah, absolutely. Absolutely.
All right. Hey, thanks. Feels really fun to start the week this way. Aurora, Chris, thanks for the energy. Christina, Adrian, hey, and talk to everybody soon.
Bye.
Have a good week, y'all. See you soon.
Bye.
Bye.